Hi everyone, welcome back to our channel. Today we are going to discuss the basics of an alternating quantity. So here we are going to discuss what is the concept of phase angle in alternating AC quantities. Okay, so how to understand this phase. Okay, so we'll have a lot of sessions on alternating quantities. Let's try to understand. Actually, an alternating quantity where E is nothing but an alternating quantity. So the induced EMF of alternating induced EMF can be written as maximum value into sinusoidal of omega t plus or minus phi, where this phi is called phase angle of the waveform. Okay, so how to understand? So where em is called the maximum value of the voltage, maximum value of the voltage, and sinusoidal where omega t, where omega is called angular velocity. Okay, so angular velocity. So actually no, we have an linear velocity. Okay, so linear velocity means we can write down it as a distance traveled by time taken. Okay, so distance means we can write down meters per second. Okay, but here how to represent this angular velocity means so angular velocity means it can be written as a radian per second. Okay, so that's why this is a linear velocity, this is an angular velocity, but this value is multiplied with omega t. Then how to write it is angular velocity omega can be written as radian by second into second. Okay, so second will cancel and this is nothing but radian. Okay, this is like an angle. Okay, so and phi is also in terms of degrees, and this omega t also you get in degrees. Therefore degrees plus degrees you can add, or degrees minus degrees you can subtract, where phase is the phi angle. So here we are going to have three phase angles. Let's try to understand. So E represents, it's nothing but the instantaneous quantity, which are generally these instantaneous quantities are instantaneous means they are available only for that instant of time at t equal to 1 second, 2 second, 3 second. Then these type of quantities are called instantaneous alternating quantity. It is represented as E maximum, maximum value of EMF into sine of omega t, where omega is called angular velocity. So radian per second into second, automatically this is also an angle, plus or minus angle. This is the proper way of writing and induced EMF. Similarly, current I can write down as maximum current multiplied with sine of omega t plus or minus phi. Now, based upon the voltage and current phase difference, we can plot the graph. Okay, so let's try to see three cases. First case one, where the phase angle is 0. Okay, so phase angle phi is equal to 0. So whenever phase angle phi is equal to 0, I can write down as the induced EMF E equal to E maximum sine of omega t plus or minus 0 degrees. Okay, and I is equal to I maximum sine of omega t plus or minus 0. Okay, here you can see here the phase difference between these two is 0. So the phase difference between the induced voltage and current is how much? Phi equal to 0. Okay, why? Because 0 minus 0. Okay, so how to draw the waveform? Okay, so you can see here the way of drawing the waveform. Let's try to draw with the two colors. So this is my induced EMF voltage. Okay, so this is the induced EMF small e, and now I want to draw the current. Okay, let us assume that the current is of some lower magnitude, and this will be like this, and this is the magnitude of current. Okay, so you can see here there is no phase angle. Okay, so the phase difference between voltage and the phase difference between E and I is 0. I can say therefore E and I are in phase. So E and I will be in phase when you draw voltage versus time, and otherwise the phase angle is 0. This is valid in the case of an resistive load. Okay, so that's why we are considering the type of load is resistive load, For resistive load, you should understand that the phase difference is 0 or voltage or current are in phase. Now, case 2, we are going to analyze. So, second one, case 2. The phase angle is positive. Okay. The phase angle phi is equal to 30 degrees. So the phase angle is 30 degrees means, so it is having 30 degrees displacement at time t equal to 0. So how to understand this? Very simple. So first draw the waveform. Okay. So this is voltage versus current. So initially I am drawing the voltage waveform. Okay. So this is the voltage waveform. So this is 0. This is pi by, so this is 2 pi, this is nothing but 5. Okay, so we are having a 0 1 and once again 0. This is an equation of b. So okay, here the phase angle is 30 means how to get is, so at this is the instant at time t equal to 0. At t equal to 0 we should have an phase angle of 30 degrees. Okay, so then how to draw that waveform is, so I'm drawing that with a red color pen. So this waveform will be here, and this is maintaining in phase of how much, so and this red waveform is somewhere like this in this axis. At t equal to 0 it is touching the instant of 30 degrees. Okay, it is having an, for example, this is the magnitude of current. If you write down, let us assume that it is a 10 at an angle of 30 degrees. You can see here at t equal to 0 the current is having an positive value of 30 degrees. So it is touching at which instant? Positive instant. So therefore, since it is touching at positive instant, the angle is how much? Plus phi. Therefore, the phase angle is phi. So you can draw it in one more style also. So when you draw this waveform on a phasor diagram, this is voltage at an angle phi, and current you are going to get, this current will have an, so current I is equal to 10 at an angle of how much degrees? 30 degrees. Okay, so the angle made in counter clockwise direction is how much now? 30 degrees. So the magnitude of the current is of 10 and angle is of 30. Then these type of loads are called as capacitive loads. And these types of loads are generally exhibited by capacitive. So if you write down this, E is equal to, I am going to write down it as E maximum sine of omega t plus 0, and I is leading, so I maximum sine of omega t plus 30. So that's how to write down. So here you can write down this as, when you write down in this form, this is Im by root 2 at an angle of 30 degrees. So this Im by root 2, I am writing it as 10 at an angle of 30 degrees. That's how I am drawing this waveform. Just understand, if phase angle is positive means at t equal to 0, the instant of touching at t equal to 0, this should be an positive instant. Then I can say that it's having a positive angle, and this is valid in the case of an capacitor. Okay, so that is case 2. Now let us see the case 3. Okay, the case of an inductive in nature. In the case of an inductive in nature, the phase angle phi should be negative. I am considering it as minus 30. Therefore, the induced EMF I can write down E is equal to E maximum sine of omega t plus or minus 0 degrees. Okay, and I is equal to I maximum sine of omega t minus 30 degrees. So minus 30 means it indicates that the waveform is having so same waveform I am drawing again and again, such a way that you get an clarity. So initially, so this is the voltage waveform. So at t equal to pi by 2, and this is at pi, this is 3 pi by 2, and this is 2 pi. Okay, so in this waveform we're going to have the multiple options. Okay, so this is pi by 2, and this is pi, and this is 2 pi by 3. Okay, so now this is the waveform of voltage, and how we will get the current is minus 30. So minus 30 means you mark half these values. Minus 30 means it has to touch at negative instant. Okay, so now I'm drawing that waveform. So the waveform somewhere it starts and it reaches to this point, and it maintains same equal to that of the voltage, and it travels somewhere else like this. Okay, so somewhere it has been started. Okay, so the waveform has already started, and at t equal to 0 it has the negative instant. So it is having a negative instant, therefore phi is equal to how much? Minus 30. So how to draw this waveform is, so now let us try to write down. This is the current I 10 at an angle of minus 30. So how to draw this waveform? Okay, if you draw the phasor diagram, I'm taking voltage as a reference, V at an angle 0. Okay, and current is how much? 10. Okay, so when you run in counter clockwise direction, then you'll get plus 5. Okay, when you move in clockwise direction, then you're going to get minus 5. So here I'm going to get, and this current magnitude is 10 at an angle of minus 30 degrees. So this angle is how much? Minus 30 degrees. So this is nothing but the Phasor representation of the waveforms. And these type of scenarios are generally for inductive types of load, and this type of current. And here you can see here, this is a voltage at an angle 0, and this is the current. I can see here voltage. What is lagging? Current lags voltage. Okay, by how much? 30 degrees. So here, sorry, current leads. Okay, current is already started, therefore current leads. This is, it is valid here. So current is lagging. Okay, so this is the reference, and it is lagging, therefore I can write down it as current lags voltage by 30 degrees in the case of an inductor. Okay, so you can understand it better as current lags voltage leads. Okay, so why? Because current is lagging. Okay, it has already started somewhere else, and voltage is leading, therefore current lags voltage lead by an angle of how much? 30 degrees. That's what we have been written here. Okay, but here voltage is leading. Okay, so sorry, here current is leading, so initial current is already started. Okay, that's how to understand the three cases of phase angle. So first case, phase angle is valid for, it has zero phase difference or phase angle is zero. But in the case of an inductor, the current can be written as I at an angle of minus 30. In the case of a capacitor, you can write it as I mean 10 at an angle of plus 30. This is valid for capacitor, and this is valid for the inductor. So this is all about how we represent the phase angle of an alternating quantities. Hope you are able to understand the concept of phase angle of an alternating quantities. Thank you for watching. So if you feel the explanation is simple, just like the video and share with your friends. And if you are watching the channel for the first time, subscribe to the channel with the name KV Tulasiram. Thank you for watching. We'll meet in the next video. Just by watching, nothing you'll get. Just you'll get an concept. We should able to draw this waveform of your own. Then you can understand. So thank you for your time. We'll meet in the next video.